G'day folks. Well, this afternoon we're going to look at an old English built repulsion motor. Brush motor. Still got to clean up this plate and find out who it's made by. I can make out 1450 RPM, half horsepower, 0.5 horsepower, 220 volt, 50 hertz. So it's pretty good. 324, probably a frame type, and motor number is A9994. Alternating current, of course. So it's obviously been a flange mount, judging by the orientation of the plate, probably vertical, maybe a pump or something like that, a transfer pump. This came off an old wood lathe or something like that. Somebody had parted the machine out and left this in the bottom of it, so I just grabbed it off as it was. The rest of the lathe wasn't worth salvaging. It's got a nice big end housing there with the brushes underneath it. I'll clean up the plates first and then we'll delve further into it and just see what kind of condition it's in. I'm guessing it was still working when the machine was taken out of service. It was a very basic, crude lathe, so this motor would probably be overkill, but then again it's only 1400 RPM, so it's not as fast as most typical brush motors. Not like the normal today's universal motors which do 12,000 revs, no problem. This is a slow revving one. Okay, that explains a lot about this motor. By Bakery Engineering Company in England, so it's probably off a mixer of some sort. Hence why it says switch off before changing, and to put 2 cupfuls of grease into the gearbox every 3 months. So it's off a big mixer. A very old one too. Number K324. It's the motor number. Yeah, it's all there. So it's a piece of bakery machinery, like a mixer, or yeah, pretty much the only thing I can think of would be a mixer. Very cool. Oh, well, let's clean it up and see what I can do, because there's the terminal. Well, probably had a switch mounted on it actually. Looks like an old switch housing. Well, don't get much to play with on this one. There's the negative wire right there, and there's the active wire, which looks like it's been rubbing through on the housing. Yeah, interesting. I might have to solder some wires onto it and then stuff heat shrinkers down as far as I can and just hope it works. Otherwise I've got to take this end housing off and hopefully not disturb anything. These old motors can be quite fragile. I think I might have to take that housing off. Though still it's down past the stator, so it's going to be tricky. Alright, we're ready for motor test. I've plugged in and turned on. Variac's off at the moment. So let's bring the voltage up a little bit. Ooh, she wants to move. We're well grounded, so a bit of luck will hold in there. Still a bit in the rough. I haven't polished the comm bars up completely. About 40 volts or so. Yeah, I'll call that 50 volts. Bearings are a bit rough. I really need to get new bearings for it. And that's it. It's wound in such a way that it won't over rev. It's only pulling a few amps. It's going through that to there to the motor. That's pretty good. It's pulled bugger all amps. This bearing noise is all I can really hear. I've got to bolt it straight to the table, like it should be. I'm pretty sure it's designed to be vertical. The feet are definitely homemade, and these studs are different style. They've got the nice gold electroplating on them, whereas the old ones are just raw steel. So someone's taken studs from something else and adapted those feet to it. It's really supposed to be a vertical mount with the bearing on the bottom taking all the thrust load. Nice, it's working well. I'll have to do some insulation tests on it though. Yeah, it's completely grounded, but I just want to do some insulation tests and other things. It took a bit of effort to get enough wire and terminate the connections inside the stator there. They're insulated with hot glue and heat shrink and other stuff, like it's glue lined heat shrink too. So that's pretty much right, but yeah, a motor as old and dicey as this, you got to be careful. I suppose the next step's just to put it straight onto single phase and try it. If the lights go out, it means I've got a short. I can probably change the direction by rotating that brush collar too. I'm not going to do that while it's running. And you'll notice the brushes aren't actually connected in series, they're actually shorted out. So it's actually opposing the magnetic field in the rotor rather than being series wound with the stator like one of these. I mean, these are normal washing machine motors like this front loader, and although it uses brushes and has a field winding, it has two separate field poles and the brushes are wound in series through it, so it goes field, brush, through the commutator bar, whatever position it's in, to the other brush, to the other field, and then out to neutral. So that's a series wound brush motor. This one here is like a repulsion induction motor. It's not repulsion start as such. I don't know. It's a bit beyond me. I don't really know the most about these old motors. Someone will probably tell me. But it's got a field winding like a normal single phase motor, but it also uses brushes which sequentially short the commutator bars and obviously induce or collapse magnetic fields in the rotor. I'm guessing because they're shorting the commutator bars, it's actually collapsing the fields in certain positions so that they will coincide with the fields from the stator. I'm sure someone will tell me how this motor works. I haven't been able to find any info on it online. Like nothing from Bakery Engineering England, distributed by Russell and Co, Lee Bank Road, Birmingham. Yeah, it's really old. That's the thing about old stuff, there's not a lot of info on it. So that's that one. We'll just do a quick test on normal AC straight into the mains, and that should do it. Alright, straight to mains. Yeah, straight in rush of current and that's it.